Hello guys, today we are going through price elasticity of supply. This is where we left off the other time. Definition: price elasticity of supply measures the degree of responsiveness of quantity supplied to changes in price. The coefficient of the elasticity of supply may be stated as elasticity of supply is equals to percentage change in quantity supplied all over percentage change in price, which is change in quantity supplied over change in price multiply price all over quantity. Because of the positive relationship between price and quantity supplied, the price elasticity of supply ranges from 0 to infinity. Types of elasticity of supply. Roman 1, perfectly inelastic, zero elastic supply. That is Roman 1. Definition of it, or the explanation of it, is supply is said to be perfectly inelastic if the quantity supplied is constant at all prices. Vertical straight line curve, elasticity supply is equals to 0. Roman 2, in elastic supply, changes in prices bring about changes in quantity supplied in less proportion. Roman 3, unit elasticity of supply, which it is described as follows: changes in price bring about changes in quantity supplied in the same proportion. Straight line through the origin curve. Elasticity supply here is 1 or unity. Roman 4, elasticity supply, changes in price bring about changes in quantity supplied in greater proportion. The supply curve is not steeply sloped. Elasticity of supply is greater than 1. Roman 5, perfectly elastic supply, price is fixed at all levels of demand. Horizontal straight line curve. Okay, it has the horizontal straight line curve. Elasticity of supply here is infinity. This is the case of government price control. We move on to factors influencing elasticity of supply. Time. In the long run, a firm will increase the input of all factors of production, and thus the supply becomes more price elastic. Availability of resources. Scarce resources already used mostly by farms lead to low output. Hence, the supply of goods and services will be price inelastic. Number of producers. More producers mean increase in output, thus supply is more elastic. Ease of storing stocks. If goods stock with ease and long shelf life, the supply will be elastic, otherwise inelastic. His increase in cost of production as compared to output. Increase in cost of production when output is increased, supply is elastic. Improvement in technology. Rapid improvement in technology, the supply of such goods will be more elastic. Stock of finished goods. In industry, high inventories stocks of finished goods, the suppliers can easily supply more, hence it is elastic. Application of elasticity of supply. If the supply of a commodity is elastic with respect to a price rise, that is Roman 1. The second Roman, if the supply is inelastic with respect to a price fall. Roman 3, the price elasticity of supply is responsible for the fact that the prices of agricultural products tend to fluctuate more than the manufactured products. We move on to determination of equilibrium. Interaction of supply and demand, equilibrium, price and quantity. Demand and supply react on one another until a position of stable equilibrium is reached, where the quantities of goods demanded equal the quantities of goods supplied. When price falls, it discourages some of the suppliers who withdraw from the market and at the same time encourage consumer who will increase their demands. This is known as buyer's market. When suppliers are only willingly to supply 90 kgs per week for 2 euros per kg, but consumers are trying to buy 200 kgs per week. These are therefore disappointed customers, and producers realize that they can raise the price. This is known as the seller's market. The equilibrium price is the market condition which one achieved tend to persist, or at which the wishes of buyers and sellers coincide. That law of demand and supply is price adjusts to that level, which equates to demand and supply. Mathematical approach to equilibrium analysis. So there is equilibrium in a single market model. Equilibrium in a single market model is assumed to hold in the market when the quantity demanded is equals to quantity supplied. QD, which is the quantity demanded, is assumed to be decreasing linear function of P, which implies that that price increases, quantity demanded decreases, and vice versa. Quantity supplied is assumed to be increasing linear function of P, which implies that as price increases, so does quantity supplied. Okay, so we will move to the linearity. Quantity demanded is equals to quantity supplied. Quantity demanded is equals to A minus B P, where AB is less than 0. That is equation Roman 1. Quantity supplied is equals to negative C plus DP, where CD is greater than 0. That is equation 2. At equilibrium, QD is equals to QS. So A minus BP is equals to negative C plus DP, whereby we get P is equals to A plus C all over B plus D. Substitute P into the function 1, which is the equation 1. QD is equals to A minus B P. So P we replace with A plus C all over B plus D. In the end we get QD is equals to AD minus BC. A single market model may contain a quadratic equation, quadratic function instead of a linear function, which is function is x1 x2 is equals to negative b plus square root of b squared minus 4ac all over 2a. So we move on. That is the quadratic function formula. Equilibrium in two commodity market. Let's assume the two commodities are linear and complementary. Say cars and petrol, which is cars is C. We assume cars is C and petrol is P. The function are quantity demanded of cars. We have this is an example. We have 820 minus 10 price which of cars minus 4 price of P. Quantity supplied of cars is equals to negative 120 plus 6 PC. Quantity demanded of petrol is equals to 590 minus 2 PC minus 6 PP. Quantity supplied of petrol is equals to negative 240 plus 4 PP. At equilibrium, we say quantity demanded for cars is equals to quantity supplied for cars, which is 820 minus 10 PC minus 4 PP is equals to negative 120 plus 6 PC. And from that equation we get 940 minus 16 PC minus 4 PP is equals to 0. When you calculate the above, you get that one. Quantity demanded for petrol is equals to quantity supplied for petrol. So we get 590 minus 2 PC minus 6 PP is equals to negative 240 plus 4P with a PP, so P with a subscript of P. 590, so we calculate that, we get 830 minus 2p with a subscript of c minus 10p with a subscript of p is equals to 0, which we get is function 2. So we multiply 2 by 8, which gives 3, subtract 1 from 3 to eliminate pc and solve for pp. So through that we get p with a subscript of p is equals to 75. So we substitute p is equals to 75 in question 1. We obtain price for cars is equals to 40. We substitute price for car is equals to 40 and price for petrol is equals to 75 into quantity D, or quantity demanded or quantity supplied for each market. So we get quantity demanded for cars is equals to 120, and on the other hand, quantity demanded for petrol is equals to 60. Yeah. So we move on to stable versus unstable equilibrium. An equilibrium is said to be stable equilibrium when economic forces tend to push the market towards it. Any divergence from the equilibrium position sets up forces which tend to restore the equilibrium. Quality per time period. At prices above OPE, there is an excess supply which pushes the prices down. At prices below OPE, there is an excess demand which pushes the price up. Quantity per time period. Price is the equilibrium price and quantity is the equilibrium quantity, which is OQE, and OPE is the equilibrium price, OQE is the equilibrium quantity. Not all equilibrium are stable. Knife edge equilibrium is a small change in price sends the system well away from the equilibrium. So here we have what we have an example. We have exercises which will not take into account. We'll move on to Kendall's coefficient of concordance, W. This is a non-parametric test used to find out if there is any agreement or concordance among raters or judges of n individuals or objects. Kendall's coefficient of concordance is given by W is equals to 12 of summation of D squared all over M squared into bracket N into bracket N squared minus 1, where W is the coefficient of concordance, D is the difference between individual sums of ranks of the raters or judges and the average sum of ranks of the object or individuals, M is the number of judges or raters, N is the number of objects. We have an example below. We have the data below shows the ranking of 10 projects by 4 judges. We have 6 columns and we have 11 rows. So the first column we have individual project, the second we have A, the third we have B, the fourth we have C, the fifth we have D. And the row is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The row contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On row 1, that is row 1, row 1 we have 1, 2, 3, 4. Row 2 we have 3, 1, 2, 2. Row 4 we have 4, 4, 1, 3. Row 5 we have 5, 5, 5, 1. Row 6 we have 2, 6, 7, 6. Row 7 we have 8, 3, 4, 7. Row 8 we have 6, 8, 6, 5. Row 9 we have 7, 7, 8, 9. Row 10 we have 10, 10, 9, 8, 9. 10, 10, 9, 8. Row 11 we have 9, 9, 10, 10. So is there any agreement or concordance among the 4 judges regarding to the 10 projects? Alpha is equals to 0.05, given that the W, which is the coefficient of concordance, we have which has a subscript of 0.05 is equals to 0.44. So the hypothesis is the null hypothesis says there is no agreement or concordance among the 4 judges as far as the 10 projects are concerned. The test hypothesis, it says there is an agreement or concordance between the 4 judges as far as the 10 projects are concerned. M, which is the number of judges operators, are 4. N is the number of objects, which are 10. We have 10 number of objects. Then there is the chi-square distribution. We have x squared 0.05 with a subscript of 0.05 comma 2, which leads to 5.99. The calculated value of Kruskal-Wallis is equals to 3.089, which is less than tabulated value of x squared, which is the Quire distribution. We accept the null hypothesis. Okay, so we move on to something else. Kruskal-Wallis test, which will continue in the next video. Thank you for watching. Thank you for your time. Kindly subscribe, like and comment. Adios, until next time.